And this is a quick review of organizing data with matrices. So we're going to talk about matrices, and so you can see I have an example up here in the top left. And this is all a matrix is a rectangular array of numbers. And so you can see we've got a couple rows, closet, 25, 35, 10, machine, 38, 25, 15, and order. And then we have some columns, right? Coat column and Sprite column and the do column. So this forms then that matrix right there. And matrices are used in a number of different areas, from simple inventory control to such things as computer-generated graphics and such, and manipulation of those graphics. So matrices, rectangular array. Now it's all about understanding the rows and the columns. So you got to keep track of the rows and the columns, right? And so obviously, this would be a 3 by 3 matrix. And you describe a matrix by its rows and columns. So you look at a matrix like this, and you're going to say, oh, okay, so this is a 3 because there's 3 rows, by 2 because there's 2 columns, right? 3 by 2. Here's the flip of that, right? Now we have 2 rows and we have 3 columns. So that's a 2 by 3. And pretty simplistic. If you look at something like this is called a row matrix. Why? Because it consists of a single row, right? And this one happens to be a 1 by 4. A row matrix will always have 1 for the row and then however many columns. And then the last example here is a column matrix, and you can see that there's only 1 column. So here we have 2 rows and 1 column, a 2 by 1. So again, how do you describe a matrix? By giving the dimensions. It's always rows, then columns, rows, then columns. All right, a little bit of notation. If I say lowercase a subscript 31, so the lowercase a refers to matrix A. So whoops, love when I do that. That's always fun. All right, so I'm referring to matrix A right here, right? That's what that lowercase a intends. And then 31, I'm talking about the 3rd row and the 1st column. So 3rd row right here and 1st column right there. So what is the value of a sub 31? It is the -8. Okay? And so that's a notation that you should know. So here, b sub 12, I'm referring to the B matrix. What is in the 1st row, 2nd column? And you're thinking it's the 4, right? All right, get my pens going here, and it is the 4. All right, so one last thought is that we can represent a matrix as a set of points as well. And so you can see I can make a matrix out of this object. And there's a couple different ways I can do it. Each point has a set of coordinates, and there are 4 points. So I'm going to have 4 points, and so I get 4 x values and 4 y values. And I can make this matrix a couple different ways, but the way I like to make my matrix to represent something like that, boy, this keeps doing it to me, sorry about that, is I like to list my x coordinates vertically and then my y coordinates vertically. So I'm just going to go left to right. Right, the x coordinate there is a -4, and then -3, and then a 1, and then way out here, right, is a 5. And then I'm simply going to put the y coordinates with the associated x. So again, back to here, now our y is 1. Next one, our y is 5. Next one, our y is 6. And the last one, our y value is 4. And there is a matrix representing our shape. Okay, now again, you can flip this and you can make the top row the x's and the bottom row the y's perfectly fine as well. And there's value to that. It can go either way. All right, matrices, a rectangular array of numbers.